Hello everyone, this is Ajay Selva from BCon India, designated as Application Engineer for Simulation in Bangalore Division. In this video, I'm going to take you through aircraft flow simulation. Before proceeding further, let's step back and see the reason for this. At times during international travel, most of us, including me, feel uneasy though seated in one place safely with seatbelts locked inside a comfortable environment with best-in-class hospitality. Yes, I'm talking about an international aircraft. I used to think why such uneasy feelings or vibrations experienced in aircraft which is under cruise in mid-air. Let's see how to find answer for these. The objective of this video is to find the answers for effect of wind forces acting on aircraft which is cruising at an high altitude in subsonic speed, followed by which how easy it is to define a project setup and how to analyze the results. This is a model representing Boeing 757 aircraft which can carry about 200 passengers. When we say subsonic, subsonic is a range used in aerospace domain to define the speed less than or equal to zero point 0.8 Mach. Mach is a dimensionless parameter obtained from a ratio of local wind speed to speed of sound. Now let's proceed and create a new project setup. This wizard tool is used to create a new project setup. I'm defining the project name as Boeing 757. Next, followed by the project name, it's the unit system. I'm convenient with Celsius. Next, what type of analysis has to be defined? Here, we're going to perform an external analysis and including heat conductions with gravity. Here, air is my default medium. I'm going to assume all other metals are titanium. And I'm defining the thermodynamic parameter with temperature as 386 degrees Celsius and the velocity parameters as Mach number with Mach number in direction Z is along Z is 0.8. These inputs are based on your global axis. The final window is the results and geometry resolution, which by default is 3, and if it is at 6 or further, it is under adaptive meshing techniques. That's an advanced meshing techniques used in the SolidWorks flow simulation. Now we're going to leave it by default value as 3 in this setup, and I'm going to finish this wizard. Now a wizard under simulation tree has been created with an enclosing box which is called as a controlled volume. With inputs, I'm going to define certain goals like average value for a static pressure. I'm going to define surface goals to see what is the pressure range acting on the wings of the aircraft when it is under cruise. Again, static pressure, average static pressure. Once our goals are defined, I can run the project, or using initial mesh, I can see the mesh distribution. Whether it is sufficient enough or I can refine it further. In this case, I'm leaving it a default one, and we can solve the study. SolidWorks flow simulation has an option called batch run, with the help of which many studies can be simultaneously solved together. But in this case, I'm going to solve only one study. Here I have an solved study which I'm going to use to analyze the results. I'm going to load the results. Now using cut plots, I'm interested in seeing what is the velocity distribution across the airfield. This gives a beautiful plot of velocity distribution along with directions in and across the aircraft. We can see a difference in velocity zone. Similarly, I'm going to hide this and I'm going to plot the Mach number. The Mach number at the tip of the fuselage is in the range of 0.2, whereas towards the end it is in the range of 0.6. And now I'm going to hide the Mach number and I'm going to play the flow field with the help of animation. With the help of flow trajectories, a simulated view of airflow can be seen across your model. And this can be recorded as well. Another beauty of SolidWorks flow simulation is report generation. A beautiful report can be generated within seconds. All I have to do is define a template, and within seconds a report is generated which includes all the input parameters and all the goals and the output parameters as well. All we need to do is add the images where and when necessary. So this is about SolidWorks flow simulation. Hope this video was helpful. Thanks for watching.